So let's read the question. ABC is an isosceles triangle in which altitudes BE and CF are drawn to equal sides AC and AB respectively. Show that these altitudes are equal. So let's go step by step. So see, we are given that ABC is an isosceles triangle. What is an isosceles triangle? A triangle in which two sides are equal. Which are these two equal sides? We are given equal sides AC and AB respectively. So in this triangle, which are the two equal sides? AB and AC. So write it down. That is AB is equal to AC. Why? This over here is given to us. Now the moment you see equal sides in a triangle, what do we conclude? Angles opposite to these equal sides are also equal. I repeat, the moment you see equal sides in a triangle, mark the angles opposite to them as equal. So what is the angle opposite to side AB? Angle C. This angle over here. What is the angle opposite to AC? B. So angle B is equal to angle C. Immediately write it. So we have angle B is equal to angle C. What is the reason? In a triangle, angles opposite to equal sides are equal. So mention it. So remember, in a triangle, the moment you see equal sides, mark the opposite angles as equal. Next, in which altitudes BE and CF are drawn. So what is an altitude? Simple. It is a perpendicular from one vertex to the opposite side. So this over here is 90. Similarly, this over here is 90. So remember, altitude is what? It is basically height, right? So whenever we talk about an altitude, it is nothing but a line segment from a vertex to the opposite side such that this over here is perpendicular to the side it falls on. Too much jargon? Simple. Altitude BE, so it will always be perpendicular to the side it is falling on. B is falling on which side? AC, so angle is 90. Similarly, CF is an altitude, so this angle will be 90. Altitude means height, height always means 90 degrees, right? So B and CF are altitudes. Now what do we have to show? We have to show that these altitudes are equal. So which are the altitudes? BE and CF. So what do we have to prove? We have to prove that BE is equal to CF. So I'll write it over here. That is to prove, we have to prove the altitudes are equal, that is BE is equal to CF. So it's very important to understand two things in a question. What is given to you and what you have to prove. So we are given that AB is equal to AC. What do we have to prove? The altitudes are equal, that is BE is equal to CF. So now how do I show that BE is equal to CF? Whenever we have to show two corresponding sides to be equal, what do? Choose two triangles which have these sides as their parts. Show the two triangles to be congruent, we'll get these two sides as equal by CPCT. So just look for two triangles which have BE and CF as their parts. So see, let's say we begin with BE. So I'll choose the triangle BEC. So I'll go with triangle BEC. I'll highlight it in red. So in triangle BEC, B is a side. Similarly, choose a triangle which has CF as its side. Triangle CFB. That is this triangle over here. This, and this. Right? So all you have to do is select two triangles which have these as their sides. Now the moment I show these two triangles to be congruent, we'll get B is equal to CF. I hope that is clear. So now let's begin. So in these two triangles, that is in triangle BFC, whichever triangle you take first. Let's say I take this triangle first, the blue one. So in triangle BFC and triangle, the red triangle, triangle BEC. Now what do I know in these two triangles which are same? First thing I see is this angle is 90, this angle is 90. So these two angles are equal, so write it. That is this angle over here, that is angle F, is equal to this angle over here, that is angle E. Why? Both are 90, so you can write over here equal to 90 degrees, and this over here is given to us. That was given to us, so do mention given. Next, I know that angle B is equal to angle C, right? Why? We just showed over here, so write it over here. That is angle B is equal to angle C. Why? Let's say we call this over here 1, so you can mention over here from 1. I repeat, over here we have stated why they are equal, call this 1 from 1. So in two triangles, I already have two corresponding angles equal. This is equal to this, and this entire angle is equal to this entire angle. Now, what else is common? See, BC is a common side. BC is part of the blue triangle. BC is also part of the red triangle. I repeat, BC is part of triangle BFC, this one over here. BC is also part of the red triangle, triangle BC. So BC is a common side, so common side is equal. So right over here, BC is equal to BC. What is the reason? Common side. So in two triangles, what have we shown to be equal? Two corresponding angles and a side. So the moment you get AAS, that means the two triangles are congruent. So whenever you have two triangles in which two corresponding angles are equal and the side is equal, they are congruent. So now let's write the congruence statement. So see, we just have one corresponding side BC and BC, right? So I'll just say triangle BC is congruent to triangle BC. Now mention 1, 2, 3 and 1, 2, 3. Now what remains? F and E. So let's say I put F over here and E over here. Now we have to verify this. How do we verify this? With the help of angles. See, angle F should correspond to angle E. So look for angle F. Angle F is third letter here. Third letter will correspond to third letter. So we are getting angle F is corresponding to angle E. Correct. Angle B should be equal to angle C. B over here is first letter. First letter will correspond to first letter. So as per this, I'm getting B is equal to B. But B should be equal to C. I repeat, C. Angle B has to be equal to angle C. So B over here is first letter. Now based on this statement, first letter will always correspond to first letter. So here first letter B is corresponding to B. But no, B should correspond to C. So what do? Swap these two. So instead of BC, I'll write CB over here. So the moment I do this, see, first letter corresponds to first letter. So angle B is equal to angle C. This is done, right? Re-verify this. Is angle F equal to angle E? Yes. Third letter is equal to third letter. Next, BC should be equal to BC. What is BC? First two letters. First two letters correspond to first two letters. CB. CB, BC, same thing. So BC is equal to BC, right? So I repeat, how do you verify your congruence statement? See, write down anything. All you have to do is match these threes. So first, angle F should correspond to angle E. What is angle F? Third letter. Third letter corresponds to third letter. So here I'm getting F is equal to E. Correct. Next, angle B should be equal to angle C. B is first letter here. First letter corresponds to first letter. So B is equal to C. Correct. Earlier it was B is equal to B. Wrong. It should be B is equal to C. So if B is first letter here, here first letter should be C. So I swap these two. Next, BC should be equal to BC. What is BC over here? First two letters. First two letters will correspond to first two letters. So BC is equal to CB. CB, BC, same thing. So BC is equal to BC. Correct. So what is the criteria I've used? Angle, angle, side. So AAS congruence criteria. So basically we have got these two triangles to be congruent. Once you have the congruence statement, you can get whatever you want corresponding paths by CPCT. So I'll copy this congruence statement again over here. So we have triangle BCF is congruent to triangle CBF, right? Now what do I want? I want B is equal to CF, right? So how do I get it? Wait, there's a problem. CBE, sorry. This is triangle. So I'll copy the congruence statement here. So triangle BCF is congruent to triangle. So I'll copy the congruence statement over here. So triangle BCF is congruent to triangle CBE, right? Now label it 1, 2, 3, 1, 2, 3. Now what do we want? We want BE is equal to CF. So search for either BE or CF in your congruence statement. Your choice. Let's say I search for BE. So where is BE in my congruence statement? Here. So BE is made up of second and third letter. So as per the congruence statement, second and third letter will correspond to second and third letter here. What is second and third letter here? BE is equal to what is second and third letter here? CF. So BE is equal to CF. It's very simple. Let's say I look for CF over here. CF is second and third letter. Second and third letter will correspond to second and third letter. Second and third letter here CF. Second and third letter here B. So BE is equal to CF. What is the reason? CPCT, corresponding parts of congruent triangles. So we have shown B is equal to CF, therefore the two altitudes are equal. Which is exactly what we had to prove. So hence proved. So hence we are done. So remember, whenever you have a figure in which you want to show two corresponding paths to be equal, it could be two corresponding sides or two corresponding angles. Generally what we do is look for two triangles which have these as their paths. For example, here I wanted to show B is equal to CF. So search for two triangles which have B and CF as their sides. So I chose triangle BEC, triangle BFC. Just show these two triangles to be congruent. How do you show it? It's based on what is given to you, right? So we're given that these two angles are 90. Next, we're given that AB is equal to AC. So we concluded angle B is equal to angle C. So two corresponding angles is equal. Next, BC is a common side, right? So with the help of what is given to you, right, you can directly use that, and based on the conclusions we get. See, this is directly given to us. This is something we concluded, right? So remember, the moment you see two equal sides in a triangle, mark the opposite angles as equal. So once you show these two triangles to be congruent, with the help of the congruence statement by CPCT, that is corresponding parts of congruent triangles, you can get your corresponding paths to be equal, right? So this is the way we have to think, right? So this is how you solve this question.